Having introduced the scheduler used to allocate access to resources to users, the next step is discussing how to simulate Llama2 on the grid using GPUs. For that, we need first to create a Conda environment in PaRI, where Conda is an open source package and environment manager. For that, we need first to open PaRI in order to be able to connect to the grid, and then we need to submit an interactive job to the batch queue system, where we can ask for a specific kind of resources to be used by the job. The following link lists the resources that are available specifically for the WSU grid. In addition to that, we can request the number of nodes. For example, here we are requesting one node, 8 cores, 10 GB of memory for 10 hours. If it's your first time using Conda, you need to type in PaRI the following command, which is conda init bash, and close PaRI and log on again. Having connected to the grid by opening PaRI again, the next step is running the interactive job again by using the same command as discussed in the previous slide. And after that, we need to create our Conda environment. For that, we need to type in PaRI the following, conda create and name our environment. In this case, the name will be LLM2. After creating our Conda environment, we need to activate it. For that, we need to type in PaRI conda activate LLM2. And after activating our environment, we need to install packages. So the seventh step will be conda install pip ipykernel scipy and Python equal 3.8, which will be the version of the Python needed to simulate Llama2 on the grid using GPUs. After that, we need also to install these packages needed for the simulation of LLM on the grid. And here we should note that we need this specific version of Torch, which is 2.0.1, since we'll be installing in the next slide the package Xformers with the following version. In addition, we need to install the following packages, which are Xformers, Transformers, Accelerate, INOPS, LangChain, BitSandBias, and LBconvert in order to be able to run Llama2 on the grid using GPUs. And here we should note that the version of these packages might be updated, and you may install each package individually by writing pip install. And the last step involves naming the kernel, which will be in our case Python LLM2. And also here we should note that it's always better to request fewer resources in order to be able to get a turn on the grid. Having created our Conda environment, the next step is to non-interactively run our job scripts using a batch script with sbatch. A batch script has two main parts. In the first part, we can request resources such as nodes, cores, and time. And in the second part, we can write commands and scripts to run as well. The batch script should be saved as the name of the script .sh, like for example llama.sh. In the next slide, we'll be showing an example of a batch script created to run Llama2 on the grid. And the example of this batch script is mainly based on the sample script in the following link. Here we show an example of a batch script needed to run Llama2 on the WSU grid using GPUs. The first line in shell scripting is a shebang that specifies which interpreter, meaning which specific software, should run the script. Next, we can give a name to our job, which will be in this case LLM test1. And then we can specify the name of the Slurm partition or queue name where the job should run. The following link lists the resources that are available, where in this case would be the partition where GPUs may be found, since our goal is to run Llama2 on the WSU grid using GPUs. In addition to that, we can specify the number of nodes and number of cores needed to run our simulation. And in this case, we are requesting one node with one core each. Also, we can specify the memory needed to run the simulation, as well as the number of GPUs per task. Here we should note that it's always better to request fewer resources in order to get a turn on the grid as soon as possible. In addition, we can request a feature as a constraint, and in this case, it would be the GPU resource of the available GPU nodes. And since we are using the WSU grid, the following link can be used in order to find the corresponding GPU resource. And also we can add our email address in order to receive notification about whether the job began, ended, and whether the job failed. And also we need to create an output file and an error file, and also we need to set the maximum runtime for the job, where we can identify the number of days needed, hours, minutes, and seconds. Having requested all the resources needed to run Llama2 on the grid using GPUs, the second part of this batch script involves initializing conda by sourcing .batchrc. For that, we need to find the path where .batchrc is. In order to do that, we can type in PuTTY the following command, pwd, and then to check whether you have this .batchrc, you can type the following command. Once you have the corresponding path, you can add it here. After initializing conda, we can activate now our conda environment, which was previously created, and in this case, our conda environment is LLM2. And then we can use the nbconvert package in order to get an output as a Jupyter notebook. Having created a batch script, the next step is running the script, which will be discussed next. Here we should note that in order to learn how to run and monitor jobs for Slurm on the WSU grid specifically, you can use the following link. After creating the batch script, the next step is to run the batch script and thus to run Llama2 on the grid using GPUs. So for that, we need to open first WinSCP, create a new folder which name can be the following, and then in this folder we need to upload both the created batch script, which is llama.sh, and the corresponding Jupyter notebook. And then we need to open PuTTY in order to be able to connect to the grid, and in order to go to the directory where the batch script and the notebook are saved, we can type in PuTTY the following command, which is cd with the name of the new folder created in WinSCP. In order to find the batch script, which is llama.sh, we can type ls in PuTTY, and then we can run the batch script by typing in PuTTY the following command, which is sbatch llama.sh. To check if the submitted job is running, we can type the following command in PuTTY. After the run is completed, we can check the results in WinSCP, where we can find the file where we can check for errors, and also the outputs generated by the LLM, which are in this case the questions generated based on the information provided as inputs to the LLM. In summary, in this tutorial, we showed how to simulate an open source LLM model, which is in this case Llama2 with 13B parameters, in Jupyter Notebook to generate a question based on an information extracted from a data set. And also, we showed how we can run Llama2 on HPC and more specifically on the WSU grid using GPUs. Thank you.